So in this video, I'm just going to show a bunch of different things about Laplace transforms, just some of the theorems you have to know when you're working with them. So first we'll talk about the first translation theorem. Which states that Laplace transform of e to the at f of t equals Laplace transform of s evaluated to s minus a. So here's an example I made up. So the Laplace transform of e to the negative 3t sine of 6t. Okay, and we'll find here that a equals negative 3. So this is kind of like evaluating the Laplace transform of sine of 6t, which we know how to do, as s shifts to s minus a, which in this case becomes s plus 3. Oops, wrong number. Okay, so the Laplace transform of sine of 6t equals 6 over s squared plus 36, and evaluate it when s shifts to s plus 3. So this becomes 6 over s plus 3 squared plus 36. And if we simplify it, we get 6 over s squared plus 3, 6s plus 45. Now there's an inverse form of this, and I'm going to show it by taking the inverse Laplace of what we just found right here. So the inverse Laplace of 6 over s squared plus 6s plus 45, written correctly that time. And this doesn't look very familiar, but if you see, we can take it over here and work on it. So 6 over s squared plus 6s plus 45, using the complete the square method. 6 divided by 2, then squared, will be 9. Because we added 9, we subtract 9. And we get 6 over s plus 3 squared plus 36. Okay, and we see that that's just the Laplace transform of sine of 6t evaluated when s is shifted to s plus 3. So, we know the shift here would be e to the negative 3t, the inverse Laplace of 6 over s squared plus 36, which again, like we said, is sine of 6t. So we get e to the negative 3t sine of 6t. Okay, and that proves how we do it backwards, because that's right there is the original function we started with up here. I'll move this down. Now we're going to talk about the second translation theorem. Okay, and that states the Laplace transform of f of t minus a, u of t minus a, where u is the Heaviside function, equals e to the negative as, Laplace transform of f at s. For my example, this will show just how you take the Laplace transform of the Heaviside function in general. We'll take the Laplace transform of ut minus 4. And that looks kind of weird until you realize that here f of t is just 1. And I'm going to write it in as 1. So 1, Heaviside function, t minus 4. Okay, and if we evaluate f of t equals 1, f of t minus a is still 1. So we can bring out the e to the negative as, here a equals 4. So e to the negative as, and f is 1, and the Laplace transform of 1 is 1 over s. Sorry, that should be a 4. And we multiply them, we get e to the negative 4s over s. So that's how that works. And I'll show you the inverse form with a different function. So the inverse Laplace of e to the negative as Laplace transform of f of s equals f of t minus a, Heaviside t minus a. Okay, so if we evaluate that, our example would be the inverse Laplace of 4 factorial over s to the 5th e to the negative 5s. Okay, so f of t, we know that if we take the inverse Laplace of 4 factorial over s to the 5, we get t to the 4th. F of t minus 5 equals t minus 5 quantity raised to the 4th. Okay, and again, we can plug that in, and that gives us our final solution. So f of t minus a is t minus 5 raised to the 4th u of t minus 5. And there's also an alternative form of this, and I find this makes it easier when you have a larger f of t with like multiple values in it, or polynomial, I guess. So alternative form. So the Laplace of f of t, Heaviside t minus a, equals e to the negative as times the Laplace transform of f of t plus a. Okay, so here's my example. Take the Laplace transform of t squared, Heaviside t minus 1. So f of t equals t squared, and a here equals 1. We can see it from here. Okay, so f of t plus 1 equals t plus 1 squared equals t squared plus 2t plus 1. And we know that is equal to e to the negative s times the Laplace transform of t squared plus 2t plus 1. And we can break that up then into several Laplace transforms and just take the Laplace of each term. So e to the negative s Laplace of t squared plus e to the negative s Laplace of 2t plus e to the negative s Laplace of 1. And our answer will be 2e to the negative s over s to the 3rd plus 2e to the negative s over s squared plus e to the negative s over s. And that's our final answer. So those were some things I struggled with, and I hope that will be able to help someone else.